So let's do one similar example. This time the means are 1 and 0. So if you look at the first graph, we have the range of the data from -3 to 2. So the mean seems closer to 0. And if you look at the graph in D, I see that the range of the data is from 0.8 to 1.2. So it makes sense the range of the data will have the mean of 1. If you look at the graph in B, then the range of the data is -1 to +4. So again, this is a situation when the mean is possibly 1. Whereas in graph C, the range of the data is -0.3 to 0.2. So no way the range can be 1. So the range has to be 0. So A and C are again the graphs with the mean 0, and B and D are the graphs with the mean 1. Now between A and C, A has a larger variation. C, the range is smaller, so the variation of the data is smaller. So I will say between the mean 0 situation, A is the one with the larger standard deviation of 1, and C is the one with the smaller standard deviation. Similarly, the range in B is from -1 to 4, so larger range, than the range in D, which is 0.8 to 1.2. So both of them are mean 1 situation, but the variation in the data in B is larger. So that should be the standard deviation 1 situation, and D should be the standard deviation 0.1 situation. Let's carry on to our next example. In this example, we will talk about the zooplanktons and phytoplanktons as two colonies. A study compared the rate of growth from different colonies of planktons. The masses in milligrams of samples of planktons from two different colonies are shown in the accompanying table. Calculate the range of the ant colony. Which colony has the greater variability according to the range? So I'm going to do it for zooplanktons. And again, I just want you to remember that the range is the highest data. Well, if you look at the highest data in this range, there is only one positive data, so that should be 0.26, minus the lowest data is going to be -6.60. So essentially this becomes a plus, so 0.26 plus 6.60, which is 6.86. Then let's work on the phytoplanktons. And we're still finding the range, and hence we will find out the larger variability. The largest data in this situation is 10.61. And the lowest data in this situation, as all the data are positive, is 0.65. So it should not be a difficult calculation. So 11 minus 5 is 6. 15 minus 6 is 9. And 9 minus 0 is 9. So 9.96. So the greater variability, of course, is the larger range. So you will say that phytoplankton has the greater variability. That's the first part of the question. Then it is asking us, calculate the standard deviation of each colony. Which colony has the greater variability according to the standard deviation? Does this concur with your answer in the previous step? So now we're going to find standard deviation. I have shown you how to calculate standard deviation manually, but we are not going to actually calculate standard deviation most of the time manually. What we will do, we will use the help of the Excel spreadsheet. So go to your Excel spreadsheets folder and you will find standard deviation, a folder there. Open it, and we're going to populate the information in the standard deviation. The only two columns we're going to put information in are the columns for X and the frequency. And we don't have to actually worry about the frequency as much. All we have to do is type in each data once and use the frequency as 1. So let's start. I have -2.37, -0.64, -2.05, -1.54, -6.6, 0.26, that should be, let me see, -6.6, and then I will have 0.26, -3, -0.68, -1.39, -0.64, -3.88. And because I have written every data once, I will just use the frequency 1 for the data I have typed in, and I need frequency only for the data. And if I scroll down, it has calculated the variance as S square and the standard deviation as S, and I need only the standard deviation, so I said that this is 1.9220 rounded to 4 decimal places. So answer to zooplankton's standard deviation .9220. And then we're going to do it the same work, but this time we will do for phytoplankton and just input the data in the spreadsheet to find the standard deviation. So again, it's just populating the data with the Excel spreadsheet. And we're going to go ahead and change the X values. I will have 10.61, 2.97, 1.58, 2.55, 5.67, 1.57, 3.04, 0.65, 2.55, 1.05, 2.11. So that's it, and we found the standard deviation to be 2.8189. So now we see that according to the standard deviation, the phytoplankton has greater variability as well. So this validates our answer that we have found in the range situation. Remember, the last question asked you, does this concur? So we'll say that yes, it concurs with our finding in the previous stage. This is a new concept, coefficient of variation. The coefficient of variation, or CV, is defined to be the ratio of the standard deviation sigma over the mean mu for the population. For the sample, this is going to be S, the standard deviation of the sample, over X bar. We'll do one more problem before we call it a day today. So find the following measures of the spread for quantitative variable types, and we're going to find range and standard deviation for each of the quantitative variable types. So we're going to do it for cylinder, and we're going to do it for engines, and we're going to do it for city mileage per gallon. So I'm going to write it this way. So first we'll do it for cylinders, and we will find the range, and then we will find the standard deviation. So let's do the range first. So cylinders, engine size, and city mileage per gallon. These are my variable types. So the range for the cylinders, the highest value is 12, the lowest value is 4, so it's pretty simple. That's 8. For engine size, the highest value is 6.7, the lowest value is 1.8. So this is going to be 17 minus 8 is 9, 5 minus 1 is 4, so 4.9. City mileage per gallon, the highest value is 41, the lowest value is 11, so that's 30. We'll find the standard deviation in each situation, so we're going to use the spreadsheet for a couple number of times, and all it requires us to do is population fill in for the X values. So let's see, the first one for cylinders, 6, 4, 6, 4, 12 and 4, and remember I told you already that we are not going to use proper frequencies. We will write down each data once, and using the frequency 1 doesn't hurt anything, and we found the standard deviation to be 3.0984. 3.0984. Now we will do it for engine size. So my data in this situation are going to be 3, 2.5, 3.5, 1.8, 6.7, 2.4, and we found the standard deviation to be 1.7543. Finally, we do it for city mileage per gallon. So we will put information as 18, 41, 18, 25, 11, 31, and the standard deviation is 10.7703. We have answered the first part of the question. Then it is asking, which measure do you find more easily understood and interpret for the data, the variance or the standard deviation? So the answer is going to be the standard deviation. And it's funny. Think about the units. If you are to say variance, then you are finding is square. So that will be, for cylinders, it will be variance unit will be cylinder square. And of course, saying cylinder square is easier to understand if someone says the variance is in terms of cylinder. And you can think of this thing about everything else as well. Like if I'm comparing between the engine size, then I would say this is the average engine size, and versus you will say that this is the average engine size square, or this is city mileage per gallon versus city mileage per gallon squared. So the easier one to understand according to the unit is the standard deviation. So we'll answer the question accordingly. We'll say that the standard deviation is the easier measure of variation to interpret as the units are easier to follow. And that will answer our question, and we are done with the measure of variation for a distribution. Next time we will start with z-score and standardization of data.